In this video, we will use LINEST and matrix solution for power series growth model regression. Here we have a dataset and we'll use the power series growth model. We show the chart and we'll use the power series as trend line. So our trend line equation is y equals 3.44 times x to the power 1.48. So this is our y equals a times x to the power b, which is equal to 3.44 times x to the power 1.48. Our value for a is 3.44, the value for b is 1.48. We will calculate these values using matrix and LINEST solution. We begin with the transformation of our dataset into the linear form. We will start to transform the formula or the equation to the linear form, which is y equals a times x to the power b. In the linear form, it will be ln y equals ln a plus b ln x because the logarithm of x to the power b is b ln x. Then factoring out the x matrix, so ln y equals 1 comma ln x, that is horizontal, which is this, and times ln a semicolon b, semicolon because it's vertical. So this is the ln a semicolon b matrix. So we begin with the ln y values. So it is Ra formula, ln of the y values. And we fill up the 1 comma the 1x matrix. So it is Ra formula, ln of the x values. Now that we have transformed our dataset into the linear form, we can use the LINEST. LINEST data y. This is now our data y and data x. And we show the full statistics. Here we have the 10 outputs of the LINEST function. We will calculate each output, and you'll notice our LNA, our B0 is LNA, so this is LNA, and our B1 is B, so this is B1. So this is B0 and B1. Our B0 is LNA. We need the value of A, so it is equal to exponent of A, LNA. That is 3.44, which matches to our equation or trendline equation, 3.44. And B, 1.48, matches to our trendline equation. And R squared, 0.9821, matches also to our trendline chart. Now we can calculate these values using slope and intercept. So we have slope of data y and data x. The intercept, data y, and data x. These values match to our LINEST output. Next, we calculate for the R square. R is cubed of data y and data x. And stay x, data y, and data x. These values match to our LINEST output. Next, we calculate for the rows, the number of rows. So n, the population, equals rows of the range. That's our population. So we can calculate the total sum of square, which is n times variance of population ln y. Next, we calculate for the regression sum of square, which is r square times total sum of squares. 12.787 matches to our LINEST output. And the degrees of freedom, which is equal to rows minus columns. So rows minus columns of the range, of the dataset range, 13, and which matches to our LINEST output. Our residual sum of square is degrees of freedom times stay x squared. Stay x to the power 2. 0.2322 matches to our LINEST output. And the f statistics, which is equal to, that is the regression sum of squares divided by 1, because there's only one independent variable, divided by stay x squared. That's to the power 2. 715.839 matches to our LINEST output. And we calculate for the last standard error value of the coefficients. We use the Pijarina inverse matrix, which is min verse m mult transpose of the 1 comma x matrix and itself. The x matrix and itself. Now we can calculate for the standard error values of the coefficient. We start with the v0, which is equal to stay x times square root of Pijarina 1. And it is 0.03468, matches to our LINEST output. And we calculate for the standard error value of B1, which is equal to stay x times square root of Pijarina 2. And it is 0.055449, matches to our LINEST output. This completes the LINEST and matrix solution for power series growth model regression.